Right. Cybersecurity is a constantly evolving battlefield, and sometimes it helps to think and act like an adversary. This is where threat emulation comes in. Threat emulation is known as adversary emulation, adversary simulation, purple teaming. A lot of words get thrown around interchangeably, but from what I understand, yeah, this is something that I've been learning and exploring lately. And from what I understand, threat simulation is when you try to mimic an adversary using TTPs linked to them. Uh, the TTPs can be associated with multiple adversaries. You're just basically trying to mimic adversary behavior. But threat emulation, from what I understand, is when you use threat intelligence to find an adversary, let's say APT 29, for example, and you do your best to mimic this one adversary. So all the TTPs and things that you use will be linked to just this one adversary. Yeah, so that's the difference between emulation and simulation. Going forward, when I say emulation, what I mean is, when you try to mimic just one adversary. Right, so that being said, a quick shout out to TryHackMe. A lot of the content for this video is based off of this module from TryHackMe, and a lot of home lab exercises that I did with my home lab setup. There's a lot of benefits for threat emulation. The main ones are it helps you identify any security gaps, and it can help test your detection and response capabilities, which ultimately improves your security posture, and it helps you manage risk better. There's a few different ways this can be done. There's a few different methodologies that you can use. The first one is MITRE ATT&CK. You can use the MITRE ATT&CK framework, which is very well known. It's very well documented. It's a large knowledge base of TTPs. You can use that to perform adversary emulation simulation. You can use atomic testing. This is something that I will talk about later on in this video. You can use atomic red team to do atomic tests, which helps in learning what malicious activity actually looks like. And the most important part about that is it provides telemetry, which is extremely valuable when you want to improve your defenses. And lastly, there's something called the TIBER EU framework. It's spelled TIBER. EU framework stands for Threat Intelligence Based Ethical Red Teaming. It's a European framework, and it was developed for emulation testing, and it could serve as a good as a guideline for adversary emulation. I won't go into details, but it has three main phases. It's preparation, testing, closure. I'll drop a link if anyone's interested in the video description. You can go check that out. But regardless of what framework or methodology you decide to use, the overall threat emulation process at a high level looks like this. The first step would be where you define your emulation objectives. This is where you would set goals, clear, specific, and measurable goals. Then you would have a phase where you do research on the adversary. This is where you would gather as much information as you possibly can, and you would select adversaries to emulate, select the TTPs that you want to include in your testing. Then there would be a phase where you plan the threat emulation engagement. This is where the schedule, scope, rules, permissions, and communication plans will be agreed upon. And then there's the interesting part where you conduct emulation. So this is the most fun part of the process. You conduct threat emulation, and lastly, the part that the business will most likely be interested in is the part where you gather your emulation results, and you can document it or produce a report, or do whatever. But yeah, that's usually the last part of the threat emulation process. There are many tools available to do this these days, yeah, but we will stick to the two well-known ones, which are open source. One is Atomic Red Team, and Caldera. It's free and open source, and I'll just stick to those two videos. But I know there are many more tools out there. A lot of them are paid. But yeah, if you decide to follow along, I highly recommend you download and install these in your local lab setup if you have one. But yeah, let's dive in. Atomic Red Team is an open source project that provides a framework for performing security testing and threat emulation. It's designed to be modular and flexible. There's several atomics available, all mapped to the MITRE ATT&CK framework. Atomics are basically just testing techniques. They all work as a standalone testing mockup to emulate a specific technique. So if I go back to the GitHub repository, go to the atomics directory, you would see all the atomics available. Every atomic has two files. So if I open this, you'll see a MD, which is a markdown file that has information about the technique, and a YAML file, which has information about the configuration and stuff. Right? And this tool, Atomic Red Team, is intended to work with the MITRE ATT&CK framework, other tools, other security tools, which is why all the technique IDs are aligned to the MITRE ATT&CK framework. And they're also available on several different platforms. So if I go back to the website and click on platforms here, you would see Windows, Linux, Mac, Azure AD, there's GCP, a lot of different cloud platforms, containers. So it works on different platforms, very widely used, a great tool, which is a good thing. Yeah, so let me download the files here. Let me download the Atomic Red Team file, and also the Invoke Atomic Tests PowerShell module. I'll drop a link to both of these in the video description. For you to download. These are not huge files, so it shouldn't take too long to download. Mine's already done. I'm going to install this to the C partition. I'm going to create a folder called Tools and install it within that. But if you do this, you'll run into an error. Yeah, as you will see in a bit, you will run into an error because Atomic Red Team, when you try running the module, yeah, it's expected to be installed at a certain location, and that's C Atomic Red Team. But since we've put this in C Tools Atomic Red Team, it's not going to work. But there are ways around it, which I'll show you in a bit. So let me extract these files here and get rid of the zip files. Yep, so that's done. If I now open PowerShell and go to the directory cd tools Atomic Red Team and install the module, so install module, invoke Atomic Red Team, and the PowerShell YAML module, just for the current user. I'll hit A and give it a few seconds to complete installing. Yeah, after that's done, let me clear this. After that's done, I'll change the PowerShell execution policy so that we don't run into any errors, and I'll make it rid of that. Now lastly, I'll import the invoke Atomic Red Team module. So if I go back to the invoke Atomic Red Team directory and type in import module invoke Atomic Red Team PSD1 force. Yeah, that should have completed the installation, but let me try running it now. Clear that. Okay, so that's before that, let me make this slightly bigger for you so that you can see better. I should have done this at the start, but yeah, apologies for that. Right, so if I try running invoke atomic test T1016, yes, as a random technique ID in show details brief, it's not going to work. And that's because the path to atomics folder variable does not have the current location, and the default location, which is C Atomic Red Team atomics, doesn't have the files. It doesn't have the tool. The files are not in that location, right? So there are two ways to tackle this. First is you can extract it to Atomic Red Team, which is what is officially recommended. Yeah. Or you can change the path to atomics folder variable, which is what I'm going to do. So PS default parameter values This would be invoke atomic test, path to atomics folder, and the exact location, which is in our case C tools atomic red theme. Let me autocomplete this atomics. There's a folder called atomics. Right, so maybe we're in the wrong directory. Let me remove this. Atomics should be there. And yeah, double quotes. And that should fix the problem. So we can test that out by using the help command. So if I type in help invoke atomic test, if you see anything here under syntax, that means it works. Yeah. So let me get rid of that. Atomic test T1016 show details brief will now show details about that technique. As you can see, there's 9 different tests available for this atomic. Yeah, so there's 9 different tests, but let me pick an atomic. Let me go back to the mitral attack navigator and just pick a random technique ID. So if I go to initial access under let's pick valid accounts, local accounts, so T1078003, right? So let's test that technique. So if I go back to PowerShell and invoke atomic test T1078003, show details brief, that will give me the available tests. In this case there are 4. Yeah, and let me view these tests in detail. So if I type in show details, it will give me a lot more details about the tests, the exact commands that it runs, the cleanup commands that it uses, and all that. As you can see, the test name here is create local account with admin privileges. That's the test number. Yeah, so these are all the commands that it will run to create a user called ART test. ART test, and this is the password that it will use, and lastly it will add it to the local administrators group. Yeah, so let's try running that and see what that looks like in action. But before that, let me check the prerequisites. So if I clear this and type in invoke atomic test T1078003, check prerequisites. As you can see, the prerequisites are not met for any of these tests, and that's because it's not an elevated PowerShell prompt. So I'm going to open a PowerShell prompt with admin privileges and basically do the same thing again. So I'm going to fast forward this bit. So import module, just do what we did earlier. Import module is not going to work because we haven't changed the bypass, the PowerShell execution policy. So let me do that. Then cd tools. Okay, so import module, import that force, and then change the variable value, and then okay, so as long as you see something under syntax here, it means that it worked. Yeah, so let me clear that and now try running this again. So invoke atomic test T1078003, check prerequisites, should now all prerequisites are met, as you can see. Yeah, so we're good to go now. We can run this. So let me run the first test here. So that would be clear. Okay, so there's different ways you can run tests. Yeah, you can use invoke atomic test, show details brief. Okay, so yeah, the first way. So you can use it. You can run it using the test number or the test name, or you can also use the unique ID for that test. So let me show you what that looks like. Invoke atomic test 1078003 test numbers 1 will run the first test here, or I can run it using the name. So I would have to paste the name here instead of the number. Not very convenient, but yeah, that's one way to do it. Or I can use the unique ID, but here I'm just going to run it with the test number. Yeah, sorry, I forgot the argument. Test number 1, and that's done running. It's all completed successfully. Since we're admin, running this as an admin administrator. If I run a net user, you would see ART test, which it's just created that user. I should have done a before to show you that that didn't exist before, but yeah, maybe later on in the video when we're running other tests. So yeah, so that's one way you can use Atomic Red Team to test your defenses. Yeah, so to see what that looks like, what the logs look like, let me jump back to the TryHackMe room and run the same thing, or I'll run a different test. To show you that. Yeah, okay, so create open two different PowerShell windows. The first one is going to run Aurora. Aurora is an EDR tool. Yeah, so let me start Aurora. Aurora is running there in the background. While that's running, yeah, let me also open the event viewer and open the sysmon logs. So sysmon logs should be under Microsoft, Windows, sysmon. Yeah, sysmon, and if I go to operational, I should see all the sysmon logs there. Yep, so I'm going to clear this log file so that it's easier for us to understand when we're examining the logs. Yeah, so let me clear that, save and clear, get rid of all of these, and then run invoke atomic test T15470001 show details brief. It's a different technique ID here. These are all the available tests here under that technique. Let me run the first one, or let me check the details first. Scrolling up. Yeah, so boot or log on auto start execution. This is the command that it runs. Basically creates run key persistence, basically creates registry entry. Yeah. Okay, so let's go back to sysmon and refresh that. There's a few logs created already. Let me clear this again. Yeah, okay, and then run this. So I'll run test number 1. Let that run. So that's created. The test is run. It's worked. Yeah, it's done executing that. Let me now go back to sysmon and see what that looks like. Click on refresh. As you can see, there are 5 entries here, and it's already, you can see that in the logs here. This is what, this is, a very useful way of testing your defenses. Yeah, by mimicking adversary behavior, you see what that looks like in your logs, what that looks like in your EDR solution, which we'll see in a second. So this is the sysmon log. Yeah, as you can see here in details, the target object here. Yeah, this was what was created. And in Aurora, if I scroll down, Aurora is not that easy to spot because of the way it is. But if you scroll down, you will see where is that? Yeah, so you'll see target object, yeah, HKU, blah blah blah. Yeah, so that is what was created during this test. Caldera is a framework designed to run autonomous adversary emulation exercises. It is built on the MITRE attack framework as well, and is an active research project at MITRE. The 3 main use cases for Caldera are autonomous red team engagements, manual red team engagements, and autonomous incident response. Meaning blue teamers can also use Caldera to perform automated incident response, but that's a topic for another video. But before we dive in and see the tool in action, let's try to understand Caldera's core terminology, which is essential to use the tool.
You would need to understand what agents, abilities, adversaries, operations, and plugins mean. Agents are programs that connect back to the Caldera server to pull and execute instructions. There are several built-in agent programs available with slightly different functionality. For example, the SunCat agent, it can use HTTP or DNS tunneling. There's the Manx agent, which can connect using TCP contact, and it works like a reverse shell. And there's the Ragdoll agent, which is a Python-based agent, and it uses HTML for communication. And abilities are TTP implementations that agents execute. They typically have information on commands to be executed, compatible platforms, payload, etc. Adversaries are groups or groups of abilities attributed to a known threat group. Right. So selecting an adversary profile will determine which abilities will be executed by the agent. And then there's operations. Operations can operations run abilities on agent groups, right? And during execution, the planner determines the order in which abilities are executed, and you can choose. There are different options to choose from. So if you choose the atomic option, all abilities will execute based on their atomic ordering. If you choose the batch option, all abilities will execute at once. And lastly, if you choose buckets, abilities will be grouped and executed by its attack tactic. And then lastly, plugins. Plugins just provide additional functionality over the core usage. Right, now that we understand Caldera's core terminology, let's see the tool in action. These machines are part of the Try Hack Me Caldera room. What you're seeing here is a browser-based Linux machine. They call it the attack box with this IP address here. And we also have access to another Windows machine, and that's which is called Victim. Yeah, as you can see, it's called Victim. So going forward, when I say Victim, I mean the Windows machine. Let's go back to the attack box and start Caldera. So open terminal, go to the directory where Caldera is saved. So CD, rooms, I think it's called Caldera, and there's another directory called Caldera within that. Let me make sure I'm in the right directory. Right, yeah, so we have to start server.py, but let me initiate a virtual environment before that, and then run the Python script. So Python 3 server.py with the argument insecure. Okay. Does the file exist? It does. Let me try Python instead of Python 3. And I think that's worked. Yeah, so it looks like Caldera has started. I'm not sure why Python 3 didn't work, but okay, let me maximize this for you. When it says okay, also since it says all systems ready, Caldera should be good to go. Let me open Firefox and go to the attack box IP, and it runs on port 8888. So we go to 8888 and log in as the red user. You can log in as a blue user as well, but for the sake of today's demonstration, let's log in as a red user. The default password for this is admin. So username red, password is admin. It's a bit laggy since this is it's a browser based. Since it's browser based, it's a bit laggy, but yeah, so as you can see, the password here is admin. Right, I'm not going to save that. Let me close this tab and log into Caldera. And yeah, as you can see, there's agents, abilities, adversaries, operations, things that we spoke about earlier, and you know what those mean by now. So let me create an agent. Let me go back to the agents tab,
and click on deploy an agent. Yeah, I'm going to choose Manx agent for this, and I'll choose Windows because we're deploying this on the victim machine, which is a Windows machine. So when you click on this, make sure to change all the IP address. So the IP address here by default is 00000000. Yeah, so we'll change that to the attack box IP address. And the agent's implant name here could be anything. I'm going to name it Chrome. Yeah, it's usually named after something like it's named after a legitimate program. But yeah, you can name it whatever you want. And let me change the IP for this as well. Right, so after all the IP is changed, this PowerShell code that you see here is what you need to paste within the victim machine. So copy that. Yeah, as you can see, we'll copy the snippet here and then paste that to the victim machine. So if I go back to the Windows machine, open PowerShell. I think this is still in CMD, so type in PowerShell, and then paste in that snippet, hit enter. Yeah, if it doesn't throw an error, it's worked. If I go back to Caldera now, I should see an agent appear. Yeah, as you can see, there's the victim host here, and this status says alive and trusted. So that's worked just like it should. Let me now add an adversary. Let's choose the enumerator adversary. So this adversary profile already has 5 abilities configured within it, right? And these can all be you can either modify these or you can run them as they are. These would be the commands executed when they run, and yeah, so let's try running an existing adversary profile, and we'll also create an adversary profile from scratch. So if I close this now and go back to operations and click on create operation, and let's name this emulation trial 1, and let me choose enumerator as the adversary, and I'll change the group to red. This would be default, and everything else are all default values, and click on start. This would run the operation, which is all those abilities that we saw earlier. You can see the status of each ability as they run. Yeah, one looks like the second one has failed for whatever reason. This is the exact command that was passed to the agent, which was run on victim machine. And if I click on view output, it shows the exact output that was seen on victim machine. Okay. Yeah, so the operation's still running. Yeah, the second one's failed, but everything else seems to be running okay. If I go to abilities and let's try creating our own operation. Let me first modify an ability. So if I go to download macro enable phishing ability, this is the code by default. As you can see, it's trying to reach out to GitHub here. Yeah, let me scroll up and show you the code. Yeah, so this variable here, URL, is a GitHub URL, and this machine here, the attack box, does not have access to GitHub, if I'm not wrong, and it's not going to work because it's reaching out to the internet.
So we need to change that. One way to do it is to host the files locally and provide that URL. So what I'm going to do is I will run a Python server by going to Caldera, the Caldera directory, which has the phishing attachment file, right? So I'm going to run a server here, Python 3 GDB server. Yep, so that should start the server, and I can change this to the attack box IP, on port 8080. And let me remove this second part of the command, which is not needed. And I think it's good to go. We save that. So this ability, what we've successfully modified an ability here, and we've saved that. So instead of reaching to GitHub by default, it will now reach out to our own attack box. There's the Python server that's running in our attack box. So let me change something here in this ability as well. So I want to change that to the downloads folder, and I want to change the name of the file to from folder to zip to exfil.zip, and also the cleanup command would need to be changed here. So I'll remove folder to zip and I'll rename that to exfil.zip, because that would be the name of the file that it creates. Let me save that and close this as well. And then let's create a new ability for Windows. The executor for this would be PowerShell. So that's PWSH. And let's name it exfiltrating hex encoded data chunks over HTTP. This ability exfiltrates file by sending chunked hex encoded data via curl get requests. Tactic would be exfiltration, and the technique ID is T1048003. Technique name is exfiltration over unencrypted. So it's that. I'm going to remove this check mark. I'm going to remove this as well. And for the command to be run here, I'm going to get that from the tryhackme room. So if I copy the command and just paste it here, again the IP here would have to be changed to the attack box IP, so 10.10.192.78. Everything else is good to go. So I'm going to save this and click on close. And let's then search for let's go to adversary profile. I'm going to clear this and choose a different profile. So if I click on new profile and type in emulation activity 1, it doesn't need a description, but if you want to provide one, you can. And click on create, and here I'm going to click on add ability. There's a few abilities that I want to add to this. The first one is download macro enabled, which is what we edited earlier today. So I'm going to add that as the first ability here. Then I'm going to add create a process using WMI query. This will be the second ability that runs. There would then be so when log on HKLM shell key persistence, well, I'm going to add this as the third ability. Fourth one is going to be identify local users. Here, and then we'll add another one. Let this be zipper folder, PowerShell. If you remember, we just edited this shortly earlier. Then last will be exfiltrating hex encoded. Yep, save and add. Right, so there's 6 abilities that we've added, some of which we modified earlier. So let me save this profile. We've saved this successfully, and then go back to operations. Yeah, let me clear this operations and run what we just created, like run an operation with the adversary profile that we just created now. So let me delete this and click on create operation. Operation name will be emulation operation test, and adversary profile will be what we just created, which is emulation activity activity 1, and that's right here, with everything else set to default. I'm going to start this. This would start the operation, and as you can see, the first ability is still running here, and it's failed. I'm not sure why that's failed, but let's check the output. Yeah, this was the command that was run. It looks okay to me, but it's failed for some reason. Output doesn't show us, doesn't tell us why. Yeah, it just says exit status 1 here, but nothing else. The second ability seems to have worked. Third is fine. So let's fix this. Let's go back to our Python server and see if we got in a request. Right, so it just says bad request syntax. Maybe something went wrong with the Python server that we just hosted. So let's go modify the ability. I have a feeling there was something wrong with the code, maybe white spaces in between, and so let me get rid of all of this and just paste the code that I copied from TryHackMe directly, and let's try again. So I'm going to restart this server, clear, and yeah, let me restart that server. Sorry, not Python 4. So Python 3. '8080. Yep. Okay, so that's done. I've replaced the code. Close that. Let me make sure I've replaced the code again. Yeah, nothing's changed actually. It looks the exact same to me, but I'll rerun this and see if that makes a difference. Right, so I can see a request come in through the server in the background, and it's worked this time. So I'm not sure what went wrong there, but yeah, it seems to be fine now. The first ability has worked, and we didn't have any issue with the other abilities, so I'm guessing they should work as well. Yeah, I'll just give it some time. Right, the second one's done. While that's running, we can see the command that was run for the second ability. This was the command, and this sorry, so the third is done, fourth, fifth, They all look completed. Right, okay, so let's jump back to the victim machine and see what this looks like for the blue teamers. So let me first open sysmon logs, which is in event viewer. So if I open event viewer, go to Windows, application, Microsoft, Windows, and then go to sysmon here, if I can find it. Yeah, sysmon, and then open operational. Yeah, so these are all the sysmon logs available here. There's about like 1,000 of those, yeah, which is a lot, but we'll clear some of these logs in a bit to see what the Caldera activity looks like. As you can see, there's a lot of these here, yeah, let's see how that goes. So if I choose one at random, yeah, this one was this run by, what was this, or this, or this. I'm trying to find a log where it's very evident to show that it was run by Caldera. Yeah, this one, for example, this was the exact command that we saw earlier. Yeah, it was run by the second ability, if I'm not wrong, or second or third ability, if I'm not wrong. And this was the exact command run, as you can see in the event viewer log. So let's go back to the command prompt and open this PowerShell module called PowerSim. Yeah, but before that, let me clear where the Windows event logs and yep. So and yeah, well, that's loaded all okay. So if I type in get win event log name and let's just say Microsoft Windows sysmon operational, it would print out all sysmon logs, yeah, in the PowerShell window here. So if you're working with PowerShell, it's this is one way you can do it, yeah. Or we can also use something called PowerSim, yeah. So if I start PowerSim here, I should see some logs come in. So let me go back to let me stop this operation and rerun this, and let me go back to the victim machine. After that's done running, go back to the victim machine, and yeah, you would see logs flow in as things happen. And this is what PowerSim looks like. It's a very useful tool. I haven't used this much, so I've heard it's useful, yeah. And this try hack me room was how I got introduced to this, so something to explore. I'm going to put that on my list. And lastly, let's see what this looks like with Aurora. So if I go back to event viewer and then just pick Aurora agent logs here, yeah, and then yeah, so that's okay, and then click on OK. Then that will just show me the Aurora EDR logs, which is about like 300 of those. And let me pick something at random and see what the details show us. So if, yeah, you can see some useful data here. So you can already understand how this could be useful to blue teamers. So yeah, that's a very interesting feature of the tool. I hope you found this video useful. This is still a topic that I'm learning more about. We saw two big well-known tools in action, and this was meant to be an introductory video, but I may make a more in-depth video at some point in the future. But if there's something specific that you're interested in about this topic, let me know in the comments. I'll see you in the next one.